descriptive statistics in Excel. In our previous classes, we've been able to establish what descriptive statistics mean. We started by looking at the measures of central tendency, the mean, the median, the mode, and also the measures of variability, standard deviation, variance. We were also able to look at normal distribution, the interquartile range. In our previous class, we've looked at skewness, kurtosis, and all of that. So today we are going to have more like a practical on what it means to do descriptive statistics in using Microsoft Excel. Okay, so this is just an overview of what it could look like. When we start data science in machine learning, is going to be much more broad, right? The output we are going to be generating when we run our analysis, our models, and all of that are going to be much more than what we are going to have in Excel. But Excel is a good place to start. Okay, so I'm going to share my Excel environment, okay, so that we walk through a data set together, and then we'll do some practical on descriptive statistics. All right. Okay, so we have this Excel. Oh, not this one. Not this one, please. Let me pick another one. Yeah, this is the Excel workbook that we'll be working with. We have a data set here on sales, a sales data set. Okay, sorry for that. So we have the sales data. This data contains product category column and sales column. We have different product category. If you use the filter to sort, so you can see that we have the furniture, office supplies, and technologies. These are the three product categories we have here. But then we have different sales. We are going to focus on the sales. We are going to do descriptive analysis on the sales data, right? And then we'll be able to look at what it means to the business and how that could impact the sales decision of the business. All right. So, but first of all, for us to be able to do this, we are going to enable an add-in. Okay, if you notice here, I have a data analysis add-in. You may not have this data analysis add-in. To be able to get this data analysis add-in to work with, you come to files, come to options, click on add-ins. When you click on add-ins, you see analysis 2-pack. Not the VBA. There is analysis 2-pack VBA. Let me see. There should be two. I think I've enabled mine anyway. But you're going to see 2 analysis 2-pack. Please, how many do you see in your own? Check. How many? Okay, because this one is for Visual Basic. All right, when you select the analysis 2-pack, or you come here, you pick Excel add-ins, right? Excel add-ins, you select Go, right? Then make sure Steven is here. Make sure you check the analysis 2-pack. Okay, make sure you check or you choose the analysis 2-pack add-in here. Then you click OK. When you click OK, you're going to get this data analysis add-in enabled. Okay, all right. Did somebody get that?
Yes, I
Someone get
did.
that? All
Yes,
right.
yes.
Awesome. Awesome. So let's continue. Okay. So now that we have our data analysis add-in enabled, we are going to select, first of all, let's select this data on sales, the column on sales. Choose data analysis, right? That is under data. Let me go back. Maybe you are maybe in home or any other menu, right? Just come to data, choose data analysis. So when you click that data analysis, you're going to see different options: ANOVA, correlation, covariance, okay, F-test, two sample for variances, all those things. Now you pick descriptive statistics and you click OK. It's going to ask you to select. I'm not sure this sales is okay. Let's try it and see, right? So select the range. The range is already selected. We have column. So make sure you choose column. This is a column, not a row that we are working on. Kate smallest, Kate largest. Normally it will still generate minimum and maximum. So I don't need largest and smallest. Confidence level of mean. Okay, let me leave this. So we have the summary statistics, confidence level of mean, that is at 95% confidence level. I will explain what that means. Okay, we can have it in a new worksheet, not an entire new workbook, right? So we click OK. So notice what it's saying. Yeah, I was skeptical about that sales here. It said input range must contain at least one data point. Oh, something is not working right. Let's do that again. So this is the input range, and I'm choosing. Okay, let me choose it myself manually, right? So I'm picking here. Notice if I click on Excel, the cell number comes. This is F13. F13. Okay, so I want to select my range here. So let me just select it. It's quite a long. Notice I skipped the sales, the title, the column title. I skipped it. I'm holding down my cursor and I'm just selecting it. A bit long. Yeah, I think I've gotten to the final. Yeah, so this is the correct range, input range. So you can actually try this with any data set that you have. Then I'll click on OK. Yeah. So notice what I have here. Can you see? So now we have an output, descriptive statistics output. Okay, we have different results here. Now, if you've not gone through our previous classes, you may not really understand what these things mean. We've been able to explain a lot of this. I think the only one we've not really explained is the standard error. I think is the standard error. So I'm going to explain that. Okay, but then we know what means. So for this sales data that we have here, we have this descriptive statistics output. Let me copy it and bring it out. Sorry. Interesting. Let me bring it back here to this place so that I can see it somewhere here. So now you've done a simple analysis, as simple as it is. You've done um, um, a descriptive analysis on this data, right? But it's one thing to run this. Anybody can run this. Can you explain it? Do you understand what it is? What is the implication of this output to sales? Okay, what is the implication? Now we have the mean value of sales as 985, right? Let's assume this is in dollars, $985. Okay, so that means the average price, the average on the average, okay, this is the sales amount, the average sales amount, right? For all the, how many data points? I think 1935, 53 rather, 1953 or 1952, excluding the first the headers, right? So we have different 1952 data points here right now, but the mean of all the values here is 985.8. Okay, so on the average, right, people on the average, the the sales of different product category on the average is around 985. Now, we have a standard error of 57. Okay, we've not really explained the standard error before this, so let me explain the standard error. Remember that we talked about different types of mean, the population and the sample mean. What does this mean? In a given frequency, we have what we call the population and the sample. Okay, so let's give an example that the alumni class of Kedros Academy, let's just an example, let's say we have 100. Of course we have more than 100 alumni, so we have 100 alumni. That is our population. Let's say the total number, or let's say okay, 200 alumni. So we have for real 200 people that have passed through Kedros Academy, right? That is our that is our population. The true realistic value is our population. And let's say that we want to, you know, we want to take the measurement, maybe their height, the height of all the alumni. We may not be able to access all the alumni at the same time to be able to take the measurements. Okay, their measurements. Maybe we want to sew alumni uniform or t-shirts or something. We are not able to get all of them, right, to take their measurement. Now what do? We now say, okay, because we don't have everybody around, let's take sample. Now out of the 200 people, we decide to work with let's say 10 or 20 people, random sample of 20 people. That is the sample, right? So we have the population. The population is the overall data set. The sample is the subset of the data set that you're working with. Do you get? Right? So here, for instance, we have 1952 data points. And I say, oh, I don't want to work with the whole 1952. I want to work with only 10% of the data. That's 195 thereabout. Okay, that is random sample. That is sample, right? There are different ways to arrive at the sample. There are different methods for sampling data, right? We may not really go into that right now, but just know that the entire population, the entire data set, the entire people that you're considering, or values or frequency that you're considering, is your population. The subset that you choose to work with is your sample. Now we have the population mean, which is the mean of the overall data, Ketros Academy alumni, the 200 people, right? Then we have the mean value. of the sample that we are working with. Remember, we've chosen to work with just 20 people out of the 200. So the 20 people is our sample, 200 people is the population. If we have the mean, the real mean, if we were to take the measurement of everybody, the mean of the measurement, the total measurement is the population mean. But the mean of that sample we have chosen is the sample mean. Do you understand? Now, the sample mean is not usually the same with the population mean. Why? Because we are not working with the full data. So for different samples, now let's say we are taking samples of 20 people. If we do that random sampling, right, for different different period of time, we can get up to 10 different samples from that same population of 200 people. If you take them 20, 20, 20. So you may draw the first 20 people and you have an average height of, let's say, 106 centimeter. Then you draw another sample again randomly, right? You get average height of maybe 120. Then you draw another sample of 20 people. Out of those 20 people, you get average height of maybe 115, something like that, like that, like that. However, the population mean is the overall average. Now, if you were to look at the real holistic overall average, you may have a population mean of 112, 112, right? Now, what is the difference between the different sample means and the population mean? The difference between the sample mean where we got 106 and the population mean of 112, the difference between the sample mean where we have 120 and the 112, the difference between the 118 and the 112. Do you understand? These are what we have as the standard error. So the standard error measures the difference between our population mean and our sample mean, which is the standard error of the mean. Okay, statistically they call it the standard error of the mean. So the lower the standard error, okay, the less variability between the sample mean and the population mean. Is that clear? Hope that's understood. Okay. So, all right. So we have the median value for this sales data. The median value here is 202.395. So if this value is arranged from the lowest to highest, the middle point, this is what we have. The mode is 90.98. The standard deviation, right? Hope you still remember standard deviation. Who remembers? Adefunke, do you remember standard deviation?
Yes.
Okay, can you explain to us briefly?
Okay. Standard deviation now.
Yeah.
How do I explain it? Like, uh, okay. Let me just try and see how I can explain it. Like, if there is a, for instance, if there is a data set now and there is
Yeah.
mean value, there's mean value, the how far the, how do I put this now? How far that particular thing varies from the mean, how far it deviates from the mean. I don't know the exact way to put it.
You mean the data point, right?
Yes, yes.
Yes. Yes. But that is actually the variance. You are getting it though. You're close by. That is the how far the data points vary from the mean is the
Yes.
variance.
Oh,
Then the standard
okay.
deviation is the square root of that
Square root.
variance.
Okay, okay, okay. Square root of that. Sorry. Thank you.
Yes, yes. So you first measure the difference between the data points, the difference between the data points and the mean. You remember that graph
Yeah.
we sketched, and then the square root of that difference. But then for standard error is now between the sample mean and the population mean, the difference between the sample mean and the population mean. Okay, so that's that is for standard deviation. We have sample variance. Sample variance. Sample variance. How do I explain sample variance? So more like, okay, let me come back here. Let me know. But more like different ways you can vary, different number of ways you can vary this data. Something like that. Okay. Yeah. So we have that. This is the sample variance. This variance is for the sample, not the population, not the entire data set. Do you understand? Well, let's come back to this. So we have kurtosis. We've explained. Please kindly mute yourself. Somebody is not muted. We've explained kurtosis. Who remembers kurtosis? Stephen, were you in kurtosis class?
Yeah, I was.
Okay, do you
Um,
remember?
I do, but I hope I will not mix it up. But I get the concept. So it was pitosis and was it skewness? One
Skewness,
of
yeah.
it, yeah, one of it was the range with which the bell curve, whether it is to the right or it tilts to the left. That was
Okay.
one of it. There was also one of it that was like well, that should be kurtosis also. I'm trying to remember, but I get it. I get the concept. Maybe I just need
So
to
the one you
just
explained is the skewness.
skewness, right? So the kurtosis was
Yes.
is the one that had this that you draw this
Details.
shaded this
Yes.
thing towards the end like this, that thing with the hair.
Yeah,
So I think that
the
one.
detailness of the data.
Okay, let me explain it now. I think that one
Mm,
is the if more of the numbers are towards the outliers, something like that. More like
exactly,
outliers.
exactly. Yeah. Yeah, so if we have more outliers, we have leptocotic. Do you remember leptocotic? A scenario where the tail is bigger. We have fat tails to the left or to the right. It doesn't matter, right? Um, then if the tail is small, we have the platocotic, and then the mesocotic is the normal curve of life, if you remember. Okay, so that is for kurtosis. So kurtosis is talking about the tailedness. Remember that day I mentioned something that um, kurtosis values, the normal kurtosis value is supposed to be, the moderate kurtosis value is supposed to be 3, just 3, just 3, right? If it is less than 3, you have low, um, you have small tail, or yeah, or very thin tail, meaning that there are no much outliers. Okay, but here we have kurtosis value of 112. That means we have so many outliers. Do you understand? So many outliers, and it explains why we have a sample variance that is so large. Okay, so many outliers, right? Now let's even look at this data physically. You are looking at it. You have a data point that is 13, then you have one that is 6,362. Do you understand? The variability is large. Notice that you even have some 5,000, you have 4. Do you see? You have the one of 9,000. So we are going to plot this on a histogram, right? Let's just continue so it will give us a better view. So if you notice it, the data sets are so varied. In fact, this mean that we have as 985 is even fair, right? But then the variability is high. Now, so we have very much outliers. That's what it means here, and which means that this is a leptocotic kind of distribution. Let's continue. Then we have skewness. Skewness is 8.5. Skewness is also high. Skewness is also high. Skewness is not supposed to be higher than 7, thereabout, right? So this is a high skewness. But then how do you know if it is a positive or negative skew? Okay, is it skew to the left or skew to the right? How would you know? Remember, we shared a formula where you have if the mean is greater than the mode and is greater than the if the mean is greater than the median and then greater than the mode, we have the positive skew or the right skew. Okay, but if the mean is less than the median, which is less than the mode, or a scenario where the mode is higher than the median, which is now higher than the mean, we have a negative skew or left skew distribution. Now, what we have here, we have mean value. How do you even reconcile this measure of the central tendency? You're having mean of 985, then you're having median of 202, then you're having mode of 90. Do you understand? So it shows you so much the variability in the data is much. Even the measures of central tendency are not central in something like that. They are not central. So in this value, we have a right skewed distribution, okay, where the peak of the bell shape, right, will be tilting more to the right side when we draw it. So we are going to look at that. And see what can we do, what can be done to what can be done to normalize something like this, or what lessons or what decisions can the business make out of this. Okay, so let's continue. We have kurtosis, we've explained skewness, we'll look at it in a graph. Then we have range. Range is difference between our maximum and minimum value, right? Do you remember? Look at it here. The minimum is 2, so the least value here is 2.25. Obviously this point here, and then the maximum is 45,737. Can you imagine? So with pointed that is, I was even seeing 6,000 and complaining. See, we have a data point that is 45,737.33. So this is the maximum data point here. Okay. The sum of everything, we know sum, we know the count, 1952, 1952, like we've seen. And the confidence level, we have the confidence interval. Now, 95% confidence means that um, the, there is only a 5% chance of the data not being accurate. Okay, so 95% minus 100, that's what that means. So the 5% chance of it, so 95% confidence interval or confidence means that to a large to 95% extent our output is accurate, so we can take it. Okay, yeah. So if it was confidence interval is more used in inferential statistics if we're to take or reject the null hypothesis, but we are not dealing with null hypothesis here, right? So in that case, we're looking at 95% confidence interval, reject null hypothesis if so value is greater than so and so, but we are not doing that. So this confidence interval, I think I selected it when I was choosing here, but you can do without it, right? It's not so. What you need here is all these, right, up to count. So this is more like, this is your descriptive statistics. This is more like your exploratory data. Now, if you want to explain this further, I've explained it. What does it mean for the sales? Let's pick this. Let's pick this table, copy it. Thank God for the era of AI. I'm going to open Bard, or let me use Bing. How many of you uses Bing or Copilot? Do you have the new Bing
Once in a
or
while.
ChatGPT? Eh?
Yeah, ChatGPT.
ChatGPT, that's what I use most.
You
Bing
can use
is my internet.
ChatGPT. Yeah, but the
We did
thing
not use it
is,
for this like this though.
yeah, for ChatGPT, except if you're using the paid version, right? The free version is GPT 3.5. Mm, it's GPT 3.5. Is the paid version that is GPT 4. That is more something something. But for sorry, let me. Okay, so let me know when for Bing is directly from OpenAI and Azure AI joined together. More like, so it's using GPT-4 directly. It's an interesting interface. Please mute yourself. I'm trying to share. That stuff. Let's come here at Bing. You want to know how I open this? Please, can you see my screen now?
Not yet.
It's blank.
Okay, if it comes up, you
Okay,
let me
coming
know.
through. It is
It's
around.
up now.
Okay, so if you come to Microsoft Bing, if you open it, right, sometimes you see a B something here, just click it, or you come here, open Copilot. Where is Copilot? Okay, this one is Copilot. Copilot is this one by the side. You can use more balance, creative. Want to do creative something, but I'm doing something analytics, so I'm using precise. So this is, you can do a lot with this. So you can use it to create wonderful images. Bing is massive if you know how to write prompts. Okay, so we've copied our table. We are going to paste it here. So let's ask, using the, okay, given, let me say given. Descriptive. Where is my tab? Okay, let me type statistics output. Explain uh, result in detail and how of a sales data. So out of a sales data below, explain the result in detail and how it's okay, let it explain first. Explain the results in detail. I'll prompt it further. Okay, I'll prompt it further. Explain the results in detail. So Shift Enter, Control V. All right. Okay, so let's submit this. What I actually enjoy most is this co-pilot part. Maybe we'll try, but let me see what the output this one is going to bring. The Bing itself will bring, sorry, let me see. It will reference, okay. Okay, I'm not okay with this output. Let me use Copilot. Let me copy the same thing. Ask Copilot. No, don't worry, paste it here. Control V. So you just explained what is average. I'm not okay with this. So let me see what Copilot has for me. Okay. Oh, I see. This is better. So what Bing does is that, of course, is referencing some sites online. But this one just give you a direct answer. So let's work with this. Okay, we have this, right? Do you see what we have? Okay, mean. So let me copy it out so that we can read it. See, you can even, there are options here you can prompt for. So let's copy this out. Let me bring it into X. Okay, or let's look at it. Let's look at it here. Now, this is the, of course, look at the mean. So it's also telling you how it's calculated by summing all sales values and dividing. Standard error measures the statistical accuracy of the mean. The smaller the standard error, the more representative the mean is of the entire data set. I've explained how you will get it, right? The difference between the sample and the population mean. So the smaller, the better, right? Because the smaller the error, the better. The smaller the better, because it shows that no much difference or gap between the real population mean and the sample. Median, most frequently occurring mode. Standard deviation measures the dispersion of sales values. A high standard deviation, yeah. So this is another measure of, explain, look at the kurtosis, measures the tailedness, like I explained, of the data distribution. A high kurtosis value like this one indicates a large number of outliers. You can see that, right? Skewness measures the asymmetry of the data distribution. A positive skewness value indicates that the tail on the right side, higher values, is longer or fatter than the left side. This is the difference between the maximum and minimum values, range, minimum, blah, 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 blah. So this statistics provide a comprehensive summary of the sales data, including central tendency and all of that. Now, what is the implication to this in terms of decision, right? So, how would the statistic, sorry, statistics output explained above impact the sales decision of the business? So let's give it a more practical, right? So how would the description output explain that will impact the sales decision of the business. So let's see what this means to the business. Hello, Chika, are you here? Is she here? Who is here? Steven, you're here, right?
Yes, I'm with you. I'm with you.
Adefunke, are you following?
Yes, I am.
Yes,
All right.
yeah, I
So
was
AI
muted.
has made our work easier now. Yeah.
Yes,
Instead
ma'am.
of having to plenty, right? So you do your analysis and then you can. So the script outreach can impact the sales decision of the business in several ways. Customer preferences, identify customer preferences. Is even giving us a fine picture safe. Must see content now. Oh, AI is sweet, sha. Okay, by summarizing the data on customer satisfaction. No, this is not giving me the output that I want. I'm talking of this particular one, not general. Customer preferences and behavior, evaluating business performance and setting goals, detecting potential problems. I did not prompt well. Okay. Recommend. I'm thinking of the right prompt that can bring up something. Let me still copy this and use it instead. Okay. From a sales data. To improve the sales of this business. Hope there's nobody in the lobby. Yeah. Well. All right. Let me just impute it again. Pam 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 pam. Using this sales data analyzed, make some smart business recommendations. Here are some recommendations to improve the sales of your business. Focus on popular products. Can you see that? The mode of the sales data is 90.98, which means that this is the most common sales value. If this corresponds to a particular product or set of products, it might be beneficial to focus marketing efforts on these popular items as they seem to resonate with your customer base. Okay, let's allow it to finish. It's making sense now, right? All right, so we have 5 wonderful points here. Okay, so we can generate more on our own. So focus on popular products. The popular product is the product ranged, the product that is sold at this price around 90.98. So we could go back and look at it now, okay, and find out if this corresponds to a particular product or set of products. It might be beneficial to focus marketing efforts on these popular items. Address high variability. The standard deviation is quite high. Yeah, indicating a large spread in the sales data. I explained that. So this could mean that sales are inconsistent with periods of high and low sales. It will be helpful to investigate the causes of this variability. Are there seasonal trends? Are certain products only popular at specific times? Answering these questions can help devise strategies to stabilize sales. Investigate outliers. The high kurtosis and skewness suggests the presence of outliers or sales values that are significantly higher than the rest. This could be due to large one-time purchases. If these outliers are significantly impacting the mean, they may be skewing your understanding of typical sales. Identifying the reasons behind these outliers could uncover new sales opportunities. Improve low selling product. The minimum sales value is quite low, which is 2.25. If this corresponds to a product or set of products, it might be worth investigating why these items are underperforming. Is it a matter of product quality, pricing, or lack of marketing? Addressing these issues could help improve overall sales. Leverage high selling products. The maximum sales value is significantly high. Okay. Understanding what is driving these high sales can provide insights into customer preferences and help in tailoring your product offerings, marketing strategy, and pricing decisions. So this makes a lot of sense. I could even create a content with this for and share. All right. So let me stop here and come back to Excel where I would show you how to do how we can look at a simple histogram. All right. Adefunke, are you still here? Adeleye,
Yes,
are you
I am here.
you're understanding what we are doing,
Yes,
right?
yes, I'm here.
Yes,
I'm,
and
I'm,
I'm
I'm following.
loving it.
Is it making sense?
Yes, it is. Like I'm feeling
Oh,
proud being a data analyst.
Please, sorry, I want to ask.
awesome.
Oh, I missed the
All
part where you did this column one, Miss Standard Dev. How did you get here?
oh my goodness, you're going to watch the recording.
Okay, no
Okay.
problem. No problem.
It was just the beginning. We first had to enable an add-in, data analysis add-in. You don't have it. So watch the recording so you get it, okay? Then you can do this. All right. Okay, so let's look at histogram. Like I said, we can use the histogram to investigate the skewness, even the kurtosis. We may not really see the kurtosis, except maybe we plot a graph around it. And then we could look at let's just look at the spread of the data anyway with the histogram, right? The histogram is what gives us the bell curve, the normal curve of light. So let's look at it. So we have the sales data. Remember, the minimum value is 2, the maximum value is 45,007 something. So it's a large, it's kind of variable. So let's look at what we get and then we can adjust this thing. So I'm going to, I've selected this, insert. So we have insert statistics chart. So this is statistic chart. If you click on it, we have histogram, Pareto, box and whisker. Remember that box and whisker when I was talking about interquartile range? Do you remember IQR? Yeah, so this is the box
Yeah,
and
yeah,
whisker. Yeah, for interquartile range. So if we're doing interquartile range, this is what we'll use. So let's pick histogram. So this is the default histogram that comes up. Let's look at it. Don't worry, we can cover this, we don't mind. Now this histogram, the histogram has been divided. Let me open it up so you see, expand it very well. I want to expand it very well. Let's see. So automatically we have first value between the lowest 2.25 to 722.25. Okay, so it has divided. Let's see, the next one is from 722 to 144, 144 to 21. So let's say the difference is about 720, right? 720, 720. If you are not okay with this, because look at what we have. I hope we still remember Excel charts. Maybe I should reduce it a bit so we can see. We still remember how to plot Excel charts, right? We've not forgotten. Yeah. So
can we use Power BI for this too? Or is it just
yes,
Excel?
you can use Power BI, you can use Tableau, but because you're already working on Excel.
Okay.
Okay. So here, so I want to adjust this. I want to see the bars more. Okay, first, let me enable the data points, data labels. Select it. So if you look at the data labels here, we have between, now notice, remember our mode is 90 point something, so we have more data points around that. Now we have out of 1953 data points, right? 1432 falls within 2.25 and 722. Do you see? Only 198 between 722 to 144, 98, one between 1442 to 2100. So you see, these are outliers. We have just one here, 11,522. We have one data point here again, 20,162. I'm looking at it manually. We have one here. This is the last one, 45,000, right? So these are outliers, you see. Now, but then the outlier, the tail is towards the right. You see, not the left. The tail of the outliers, can you see it's by your right? Okay, let's say we adjust. Let's try to adjust this. So if I click on this down part, if I click on it and right click and say, let me format this axis. So you see bin. These are the bins. These different divisions are the bins. The bin width. Let me increase it to 1000 and see. So it will be easy to read. Oh, someone is at the lobby. Okay. Oh, thank you for admitting the person. So we've increased the bin to 1000. Okay. So increasing the bin to 1000, I want to see it more. It's easier to understand. Bins are the width, the way histogram divides your data. So let me close this. Now increasing the bin. So we have from 2.25 to 1000, 2.25. So this is the first 1000 data points. We have 1531. So when we have mode, remember the recommendation we have, one of the recommendations is that we focus on the popular products that is selling around that 90, is it 90 USD or whatever? Do you understand? 90 point something. Wow. So yeah, between 2.25 and 1000, the first 1000 data points, the first 1000 values, we have 1531 data points in this first set of values. Then the next 1000, next 1000, from 1000 to 2000, 2000 to 3000, 3000 to 4000. So we've divided them. Now we have 11 data points from 9000 to 10,000. We have 3 data points from 12,000 to, so you see. Now imagine if we look, this is not a bell curve, this is not a normal curve. A bell curve, you have it up and down. Sorry, I'm not using pen today, but this is, you can see it is skewed. The skewness is to the right, the tail is to the right. So this is a right skewed distribution. Do you see that? This is, by mere looking at it, this is a right skewed distribution. most of the data points are here, and most of the data points are here at the left, the topmost, while the tail is towards the right. And this is why we have a very high kurtosis. Let me reduce it back. Both skewness and kurtosis, very, very high. So what can be done, right? In a scenario where, well, this is sales. For sales, what we can do is, of course, focus on the popular products, look at the underperforming products that are selling at $2. Maybe we do away with them, or we improve the product quality so that the sales will come up. The ones that are performing so well, like this outlier here that is 45,000, what can we do to increase, have more of that, that kind of sale, of course. And then, another thing I would bring to our notices, if this is a kind of machine learning data, you would not have to work with it like this. Now, you wouldn't have to work with it like this. Okay? The standard error here, let's say on a scale from 0 to 100, is just more like average, right? There are lots of up and down between the mean and the population mean and the sample mean, right? If you are to normalize the data, if you're to do data transformation, if this was an exam or an interview and then you were told to now transform this data, if you're looking at the standard error, you could um increase the sample size. Okay, so instead of us, I gave us example of using 20 sample of 20 people from alumni class instead of 200. We could increase it to 50. It will be a better representation of the population, or 100. The more you increase the population, the more you increase the sample, the less the variability. Do you understand? That's one thing you can do. Another thing you can do in a scenario like this is you can do square roots. Yeah, you can also do square roots. You can take the square root of this particular entire table column. So you could duplicate the column here with a formula. Take the square root of this first one equal to square root, use formulas, use the square root, blah blah blah, and then get the square root of everything. And then you check the this thing again. Okay, that's another thing you can do. Okay, that's another thing. We've spent time, 1 hour 20 minutes. That's another thing you can do. You can take square root of the data. Okay, but then if it's in machine learning, you can just normalize, and it just run operations to just tell you what it's doing, taking sometimes the square root, sometimes the logarithm of the data points. Okay, sometimes we take the logarithm of the data points, sometimes anything it can do, system will just do the right thing, and then you'll have a better result. Do you understand? Okay, so let me see, do we have any question before we continue, before we call it a night? I'm not even continue. This is 8:23. For those that come late, please watch this record though. Let me ask Binks a question.